Hi everybody, I am Sankareswari, Assistant Professor of Physics, VV Vanniyaperumal College for Women, Virudhunagar. I am going to explain about radioactive waste management. So energy emitted from a source is generally referred as radiation. Examples include heat or light from the sun, microwaves from an urn, X-rays from an X-ray tube and gamma rays. So the most common form of radiation we are all familiar with is visible light. Background radiation is around us all the time. It comes from many sources including the ground, the sun and the food we eat and drink. The total amount of radiation we experience day to day is low. On average, about 84% of background radiation is from natural sources and 15% from medical practices. Less than 1% comes from nuclear power, industrial and defense activities. Radioactive materials have many uses in industry, agriculture, medicine and research. The three most common types of radiation are alpha particles, beta particles and gamma rays. Radiation can damage the DNA. DNA is nothing but the hereditary material in humans and almost all other organisms. High dosage of radiation can cause acute radiation syndrome or cutaneous radiation injuries. Cutaneous and radiation injury happens when exposure to a large dose of radiation and it causes injury to the skin. High doses of radiation could also lead to cancer later in life. Acute radiation syndrome is an acute illness caused by irradiation of the entire body by a high dose of penetrating radiation in a very short period of time, usually a matter of minutes. Radioactivity is the act of emitting radiation spontaneously. This is done by an atomic nucleus that for some reason is unstable. It wants to give up some energy in order to shift to a more stable configuration. So examples for radioactive substances are uranium and thorium. Radioactive materials have many uses in industry, agriculture, medicine and research. We use radioactive materials to produce electricity from nuclear energy, to diagnose diseases and injuries by using X-rays and CT scans, to treat cancer through radiation therapy and radiopharmaceuticals, to preserve food by killing bacteria, to sterilize medical equipment, to measure the thickness of structures and materials, to support defense programs in nuclear weapons and submarine propulsion. Ionizing radiation is not detectable by one's senses. It cannot be seen, heard, smelled, tasted or felt. So, we handle radioactive sources safely by wearing a lab coat. If there is a risk of serious contamination, wear disposable clothing. Always wear gloves when handling radioactive substances. Wear shoe covers in rooms where the floor may be contaminated. Keep personal items such as handbags etc. outside the lab. People who are externally contaminated with radioactive material can contaminate other people or surfaces that they touch. For example, people who have radioactive dust on their clothing may spread the radioactive dust even they sit in chairs or hug other people. So we can minimize the radiation by the two ways. One is distance. Just as the heat from a fire reduces as you move further away, the dose of radiation also reduces dramatically as you increase your distance from the source. By using shielding also, we can minimize the radiation risk, that is by using barriers of lead, concrete or water, provide protection from penetrating gamma rays. At a distance of 40 to 45 miles, a person would have at most 3 hours after the fallout begin to find shelter. Considerably smaller radiation dosages will make people seriously ill. So covering our mouth and nose with a mask, cloth or towel can help only to reduce the amount of radioactive material we breathe. Waste management involves the processes of waste collection, transportation, processing as well as waste recycling or disposal. These services can prevent the environment from being harmed. Reducing waste will not only protect the environment but will also save on cost or reduce expenses for disposal. Radioactive waste management refers to the safe treatment, storage and disposal of liquid, solid and gas discharge from nuclear industry operations with the goal of protecting people and the environment. So problems caused by the mismanagement of waste are air emissions, health impact, ecosystem services in danger, soil contamination, surface and groundwater may be affected, marine pollution, odor and littering, pests. Radioactive wastes are stored so as to avoid any chance of radiation exposure to people or any pollution. The radioactivity of the waste decays with time, providing a strong incentive to store high-level waste for about 50 years before disposal. Spent nuclear fuel is dangerously radioactive and has the potential to release a poisonous chemical element called plutonium into the environment. In fact, exposure to radioactive waste can cause cancerous growths in humans and genetic damage or mutation to animals and plants. Radioactive waste is generated not only by the nuclear power industry but also by hospitals, universities and non-nuclear industries. All the regulations applying to waste in general also apply to radioactive waste. However, radioactive waste emits radiation which makes it a particular hazard for human health and the environment. It must therefore be managed with special care from generation to final disposal. Finding suitable waste disposal solutions is a major challenge for all stakeholders, industry, regulatory authorities, public authorities, local communities and the population. So radioactive waste includes the following. One is leftover fuels that were used in nuclear power plants to generate electricity. The other is the waste made by facilities involved in nuclear weapons. Spent nuclear fuel can be recycled to make new fuel and byproducts. The radioactive elements cannot be destroyed by any known chemical or mechanical process. Their ultimate destruction is through radio decay to stable isotopes or by nuclear transmutation by bombardment with atomic particles. Consequently, radioactive waste management consists of controlling and reducing the radioactive releases to tolerable levels, concentrating them into a form which can be stored or disposed of in such a manner that they do not later appear in hazardous concentrations in the biosphere. The radioactive wastes are classified according to its physical form, that is solid, liquid and gaseous, according to its activity, that is low radioactivity, medium and high activity, and its half-life period. It may have short half-life, medium half-life and long half-life. Half-life period is nothing but the time required for the half of the radioactive material to disintegrate. So the figure shows the steps for radioactive waste management. It includes waste generation, conditioning, retrieval, pre-treatment, storage and disposal. So waste management covers the whole process of waste handling, waste collection, waste segregation and transfer, waste treatment, waste conditioning, waste storage and waste disposal. The next one, storage. Storage means storing or keeping conditioned radioactive waste in a proper safe place or facility with the intention to retrieve it back at some time in the future. The store should be located to minimize radiation risk. The location should be selected with due consideration given on the following conditions. It should be isolated area, low risk of flood and fire. It must be stable in order to secure waste from leakage or dispersion of radionuclides to the environment over a period of time, free from earthquake threat. The final part of radioactive waste management process is the disposal. It is considered only there is no intention to recycle or reuse the radioactive waste. The three basic principles of radioactive waste disposal are delay and decay, dilute and disperse, concentrate and contain. Radioactive waste disposal site should be properly selected to ensure its suitability and safety to members of the public. So the disposal methods involve are shallow land burial, that is the near surface, and deep ocean or seabed disposal. So the generation of waste can be minimized through the following three odd steps, that is reduce the amount or volume of the radioactive material being used, reuse the use of materials or sources, or do decontamination process, recycle the usage of sources in the same or different fields. The figure shows the disposal of the radioactive waste. Thank you.